Hello, good students. Welcome back to our channel, Learn with Jobs. And today we are discussing on trigonometric identities. Let's start. Now, this is our first question. Prove that tangent square x times, in the bracket we have cosecant square x minus 1 equals to 1. Okay, so as you see here, we have an equation, yeah, and these equations consist of the expression on the left hand side and a value on the right hand side. Now, what I give you here is considered as simple trigonometric identities. So the idea is we try to figure out or to simplify whether this can be written after the simplification as 1. Okay, so let's start by taking the left hand side expression, okay, which is tangent square x times cosecant square x minus 1. Now, we try to simplify this, whether it can be written as 1 or not. To do this, we need to remember some principle. What I mean by principle here is the formula for the simple trigonometric identities. Here we have tangent and cosecant. Yeah, tangent square x, cosecant square x. Now, can you remember the identity for tangent and cosecant? Can you remember what you can write? So, as we know, tangent is actually, this is tangent x, sine x out of cosine x. Meanwhile, cosecant x is actually the reciprocal of sine. So the y cosecant x is 1 out of sine x. Okay, the next step, after I remember this, I try to figure out, yeah, this is square, so it means I can make it like this, sine square x out of cosine square x. Basically, it will give you the same formula, right? So sine square x out of cosine square x is equal to tangent square x. Yeah, it doesn't matter. That's the same thing. And this one as well, I make it become 1 out of sine square x minus 1. Now, you can see that here. It's really clear, yeah? Then, since this is outside of the bracket, and inside the bracket we have, inside the bracket we have 1 out of sine square x minus 1. So we can distribute this to the bracket. What I mean here, just multiply this into the term inside the bracket. So what we have is sine square x out of cosine square x times, okay, 1 out of sine square x minus sine square x out of cosine square x. And as you see here, we can cancel this, right? Because it gives you 1. And you will have 1 out of cosine square x minus sine square x out of cosine square x. Okay, now after this, we try to simplify again. As you see, they have the same denominators now, which is cosine square x. So this can be written as 1 minus sine square x out of cosine square x. Okay, and then what we have here, remember, 1 minus sine square x is equals to what? Do you know? Do you know that? I think this is part of the basic identity. Basic trigonometric identity. So 1 equals to sine square x plus cosine square x. You remember this? Or you can write sine square x plus cosine square x equals to 1. It's the same thing. Yeah, this is basic trigonometric identity that you need to remember. As you see, cosine square x is actually 1 minus sine square x. Okay, why? Yeah, we know this. So 1 minus sine square x is actually cosine square x. So I just substitute this. Yeah, 1 minus sine square x become cos square x. So cos square x out of cos square x, it will give you 1. And so that's why our trigonometric identity is acceptable, or it is proven that tangent square x times cosecant square x minus 1 is equals to 1. Now it is proven. Now, as you see here, right? This is our first example. So, what do you think? Not difficult at all? All right? Okay. This is the first problem. Now we come to the second problem. Let's see what we have. Okay, so I put it here, yeah? Now, on the second question, I have proof. Now I'm using blue color, yeah? Proof secant square x times cosecant square x is equal to secant square x plus cosecant square x. Now, look at this. What will you do? As you see here, yeah, on the both side we have different expression. The first one is this one, secant square x times cosecant square x, multiplication, right? And here on the right hand side, we have the addition, right? Secant square x plus cosecant square x. Now, what will we do? Which one we need to simplify? Like, uh, what I have said before, you can choose either left-hand side and right-hand side. But I bet that you will confuse a bit, right? To choose which one is the easiest one to simplify. Okay, what do you think? Allow me to give you time to think which expression we need to simplify so far. What do you think? Left-hand side or right-hand side? Actually, you can try one by one, yeah? Because this is only practice, yeah, exercise for us. So you can choose one by one. You can try to do that with left-hand side. It doesn't matter, yeah? But again, while you are picking up either left-hand side or right-hand side, make sure that the expression can be simplified into the other expression, right? They will be the same. Now, for this, I prefer to take the right-hand side. Yeah, usually trigonometric identities, they normally put the complicated expression or the unique one on the left-hand side. But as I told you before, once again, that sometimes they will put it on the right-hand side. So for this, I think I will choose a right-hand side, which is secant square x plus cosecant square x. Okay, then as we know, recall, yeah, we are recalling that there are several basic trigonometric identities that you have to remember and understand. As you see, secant is actually the reciprocal of cosine. So secant x equals to 1 over cosine x, as well as cosecant, which is, yeah, from the previous question, the reciprocal of sine x. Okay, so the next step, I substitute or I write this by using 1 cosine because we have square here, so 1 out of cosine square x, right? Plus 1 out of sine square x. Okay, now this is fraction, yeah, and mathematically you can do this easily. Just make the denominator the same. So what I do here, okay, this must be sine square x out of, yeah, out of what? Okay, later, this one plus cosine square x out of, nah, you multiply this, right? So cosine square x times sine square x. Okay, next. Once again, as you see, look at this. Now, look at this. Sine square x plus cosine square x, right? Remember, We have this also in the previous question. Sine square x plus cosine square x, it gives you 1. So we can express this with 1. So 1 out of cosine square x sine square x. Am I right? Okay, after this, what will you do? You have this expression now so far. Yeah, we can split this. Yeah, this is multiplication, right? Remember, 1 out of cosine square x times 1 out of sine square x. And I put here, yeah, this equals to 1 out of cosine square x is equal to secant square x. Meanwhile, 1 over sine square x is equals to cosecant square x. Now, as you see, okay, we have proven our trigonometric identities that secant square x times cosecant square x is actually what? Is actually what? Sorry. It's actually, as you see the question here, yeah, it is. Oops. This is secant square x plus cosecant square x. Nah, can you see that? Nah, okay, let's see. Yeah, it is proven, right? So, what do you think? Is it difficult? Hmm? Not really, yeah? Not really. Okay, so the idea is you need to remember the basic, yeah? You need to remember the basic trigonometric identities, such as this one, the reciprocal, or tangent x is equal to sine x, or the cosine x, and also this, where sine square x plus cosine square x is equals to 1. Okay, I think that's for today. We will try to make another examples about trigonometric identities. Yeah, later on the next video. I think you can enjoy the explanation and you can understand it very well. Yeah, thank you for today. Thank you for your kind attention and see you. Bye bye.